In this video, we shall continue with 4C, problems 2.3 from elementary number theory by D.M. Burton. We have to use mathematical induction to show that 5 divides 3 to the power 3n plus 1 plus 2 to the power n plus 1. Okay, let's do this. First, we check for n equal to 1. When n is equal to 1, 3 to the power 3n plus 1 plus 2 to the power n plus 1 is equal to 3 to the power 3 into 1 plus 1 plus 2 to the power 1 plus 1, which is 85, and 85 is divisible by 5. So the result is true for n equal to 1. Now we check for n equal to k. 3 to the power 3n plus 1 plus 2 to the power n plus 1 becomes 3 to the power 3k plus 1 plus 2 to the power k plus 1. Let this one be divisible by 5. If it is divisible by 5, then 3 to the power 3k plus 1 plus 2 to the power k plus 1 is equal to 5m, where m is an integer. Now we have to show that the result is also true for n equal to k plus 1. Now, when n is equal to k plus 1, 3 to the power 3n plus 1 plus 2 to the power n plus 1 is equal to 3 to the power 3k plus 1 plus 1 plus 2 to the power k plus 1 plus 1. Here we get 3 to the power 3k plus 4 plus 2 to the power k plus 2. Okay, now look here. Here we can write this one, 3 to the power 3k plus 1 into 3 to the power 3. It's the same. Okay, the reason that I split this one into these is because I want to use this one. Okay, see here, 3 to the power 3k plus 1, and here we have 2 to the power k plus 1 into 2. Same reason, because here we have 2 to the power k plus 1. Now from here we have 3 cube and here 2. So it's not easy to replace this one by 5m because of these two, 3 cube and 2. So what we do, we modify this one a bit so as to be able to write 3 to the power 3k plus 1 plus 2 to the power k plus 1 as 5m. So how to do that? Let's see here. Here, if I add 2 to the power k plus 1 3 cube, then I get or not 3 cube into 3 to the power 3k plus 1 plus 2 to the power k plus 1, and that is equal to 5m. Yes, I get. Okay, since I have added this one, I have to subtract by the same term into 3 cube. Okay, so what do we do? Here we have common 3 cube, and then I have 3 to the power 3k plus 1 plus 2 to the power k plus 1. Okay, and here common is 2 to the power k plus 1 minus 2 to the power k plus 1 into 3 cube. Okay, and then here we have minus 2. Now what is this? It is equal to 5m. Okay, so here we can write this one is 27, and then we have into 5m minus 2 to the power k plus 1. 3 cube minus 2 is how much? It is 25. Okay, 25. Now here we take common by 5, we have 27m minus 5 into 2 to the power k plus 1. Okay, so see, now we see that this term 3 to the power 3n plus 1 plus 2 to the power n plus 1 is equal to 5 into this factor, into this term, which is a multiple of 5. So what can we say about this one? From here we conclude that it implies that 5 divides, since it is a multiple of 5, then 5 divides 3 to the power 3k plus 1 plus 1 plus 2 to the power k plus 1 plus 1. So using mathematical induction we conclude that 5 divides 3 to the power 3n plus 1 plus 2 to the power n plus 1. Okay, so this is for number C. Now similarly we follow the same procedure for number D. So let's do that. Number D, when n is equal to 1, 4 to the power n plus 1 plus 5 to the power 2n minus 1 is equal to 4 1 plus 1 plus 5 2 into 1 minus 1, and this one is equal to, so 4 square plus 5, it is 21. Okay, now 21 is divisible by 21, so the result is true for n is equal to 1. Now we check when n is equal to k. Now when n is equal to k, 4 to the power n plus 1 plus 5 to the power 2n minus 1 is equal to 4k plus 1 plus 5 2k minus 1. Suppose this one is divisible by 21. If it is divisible by 21, then what can we write? 4 to the power k plus 1 plus 5 to the power 2k minus 1 can be written as 27m, where m is an integer. Okay, it can be written as a multiple of 21. So now we show that the result is also true when n is equal to k plus 1. When n is equal to k plus 1, what do we have? 4 to the power n plus 1 plus 5 to the power 2n minus 1 is equal to 4 k plus 1 plus 1 plus 5 2k plus 1 minus 1. This one is equal to 4 to the power k plus 2 plus 5 to the power 2k plus 1. Okay, in the same way, now here we can write this one as k plus 1, 4 to the power k plus 1 into 4. It's the same. I'm writing this one like this because I want to use this one. Okay, here also 5 to the power 2k plus 1 can be written as 5 to the power 2k minus 1 into 5 square. It's the same. Okay, this one gives back 5 to the power 2k plus 1. Okay, so now, but here we have 4, here 5 square. So how to do in order for us to be able to use this one? We modify this. So what do? We add 5. Here we have to add 4 into 5 to the power 2k minus 1. If I add this, then from here I have common 4. then I have 4 to the power k plus 1 plus 5 to the power 2k minus 1. Then I can use this one. Okay, since I have added this one, then I have to subtract by the same term. Alright, so now see, from here we have common 4 to the power k plus 1 plus 5 to the power 2k minus 1. And then from here we have minus 5 to the power 2k minus 1 into 4 and then into minus 5 square. Okay, and from here what do we have? What is this? 21m. Now we have 21m into 4, okay, minus 5 to the power 2k minus 1. 5 square is 25. Now minus 25 with 4 we have minus 21. Okay, so now this one we have like this, minus into minus we have plus, and then 5 to the power 2k minus 1 into 21. Now we see that 21 is common, so 21 into 4m plus 5 to the power 2k minus 1. Now see, this one, okay, this is a multiple of 21, so it implies that 21 divides 4 to the power k plus 1 plus 1 plus 5 to the power 2k plus 1 minus 1. So using mathematical induction, we conclude that 21 divides 4 to the power n plus 1 plus 5 to the power 2n minus 1.